My name is Wes Novak. I work at Pluralsight as a systems engineer, focusing on cloud ops, DevOps, SysOps, etc. Lots of different things. So in this talk, we're going to be talking about the AWS CLI and shell scripting and how you can do some automation using those. So I'm going to introduce everything, go step by step. At the end of the presentation, I'm going to have links to download the presentation, and I also have a GitHub link at the end that you can download all of the code that I'm demonstrating during the talk. So let's get started. Because of the short format, I'm also not going to take any questions, but after the presentation, I'll be in the hallway happy to talk to everybody and answer any questions you have. So the AWS CLI is the command line interface to Amazon Web Services. It is a single tool that you can use to interface and interact with all of Amazon's various services. And that's pretty impressive because of the dozens and dozens of Amazon services that are out there. They're all run by separate AWS teams that have their own ideas about how they want their APIs to look and function. And they use different verbs for different actions and things of that such. So Amazon bringing that all together in one CLI to allow you to interact with all of the services is a very, very helpful thing. So it's the one tool. You can hit all of those Amazon services using it. The easiest way, the recommended way to install is with pip. So you can do pip install AWS CLI --upgrade user. That will install it just for your user instead of for the entire system. And you can use the AWS CLI on Linux systems, on Mac OS, and on Windows. So the CLI is supported on all major client computing environments. So after you get to the AWS CLI installed, the first thing you're going to want to run is AWS configure. And the AWS configure is the command that helps you initialize your AWS CLI and set up your environment so that you can actually do some things with the CLI. And the configure is going to run you through a couple of prompts here to provide your AWS access key ID, your AWS secret access key. It's going to ask for a default region and a default output format as well. So to use the CLI, you need to generate a set of AWS access keys and a secret access key. And I'm going to take a moment real quick here to mention that with AWS, when you initially create an AWS account, you have what's called a root user. You can create access keys for a root user, but that is very bad practice and you never want to do that. So please do not use any root user keys. That is the keys to the kingdom. A lot higher risk if you do that, especially if it's used by multiple people. If it gets embedded in critical production application processes, then you're in a bad situation. So ensure that you are using IAM users. So IAM is identity, and let's see, the identity service for AWS that allows you to create users so that you don't have to use that root user. And you can create those access keys per user and lock down the permissions for those users so that your keys don't have permission to the entire AWS account. When you're configuring your AWS CLI, you'll notice here in the top I have -- profile parameter listed here. And you can do that. That is optional. If you only have one set of access keys and you run AWS configure, it's going to just create this default profile for you to use. But if you have multiple AWS accounts or you have multiple IAM users, that have different levels of access, then you're probably going to want to use what AWS calls named profiles. And you can specify the named profile by using that -- profile parameter and then creating or setting the name of that named profile. And then you can use that later in your scripts or your AWS CLI commands in order to access the credentials for that named profile. So again, that's the named profile. It's optional. If you have only one set of keys, you don't need to use it. But if you have many accounts, many different sets of keys, then you're going to want to use named profiles. So also next going to talk about the config files that AWS CLI uses. We've got a home/.aws/config file. And then we have a home/.aws/credentials file. And these are the two main files that the AWS CLI leverages. So the top one is going to specify default region and output formats for each profile. And the bottom one is actually going to store those keys that you specify when you're running that AWS configure command. It's important to note that the CLI stores these files, including your secret access key, in plain text on the file system. So you want to make sure that your disk is encrypted. Use full disk encryption if you can. But if you're not using full disk encryption, definitely make sure that you're encrypting this particular file. Because if you have keys that have administrative privileges and they're sitting there unencrypted on your disk, that's bad. And it could lead to some loss or leakage of your keys. So let's look at those files really quickly. The first file, again, is that .aws/config file. It looks something like this. So again, at the top here, it's got the default profile that I mentioned. That's going to be the very first set of credentials you set when you run AWS configure without that -- profile parameter. And then below, you'll see in square brackets, I have 3 different named profiles listed in this example. I've named one dev, one staged, one prod, and they each have different default regions. So a lot of the AWS CLI commands that you run are only going to be scoped to a particular region. So if you have all of your resources in one particular region, or mostly in one region, you're probably going to want to set your default region appropriately so that you don't have to use the -- region parameter on every single command that you run. Next up is that .aws/credentials file. And again, as mentioned earlier, this stores your AWS access key ID, which is just an identifier. That's not a privileged piece of information. But it also stores that AWS secret access key, which is the secret part of your keys that you don't want to divulge and you don't want leaked and you want to make sure is encrypted. So you can see again here we're using a default profile and then different named profiles in square brackets here so that you can leverage multiple keys and different types of credentials with the one AWS CLI tool. All right, so next I'm going to talk about configuration settings and precedents. So when you're using the AWS CLI, you can store different settings and different credentials in various places. And the CLI will use this hierarchy of precedence to determine which of those settings to use if you have multiple of them set. So the highest level option of precedence is going to be the command line options. And those include region and profile. So when you're running an AWS CLI command, you can do -- profile dev. That specifies that named profile to use for this command. You can also do -- region, as I mentioned earlier, and specify the region. That's going to be the highest level of precedence that overrides everything else. Next up is environment variables. So you can set your access key ID, your secret access key, AWS session token, lots of other things can be set in environment variables in your shell. And that's the next order of precedence. After that is your credentials file, which we looked at a second ago. And after that is your configuration file. Next up is your container credentials. So this really is only relevant if you're using Amazon's Elastic Container Service. And then lastly is instance profile credentials. So when you're launching an EC2 instance in Amazon, you can set a EC2 instance profile, which is associated with a role. And your instance then has permissions that are associated with that role. So you never want to use the AWS CLI on an EC2 instance itself with credentials dropped on that instance. Because again, then you're going to have to worry about rotating those credentials, access to those credentials, things of that nature. So whenever you're running CLI type scripting on an EC2 instance, make sure to use instance profile and a role. Okay, so let's take a look at, talk about environment variables really quickly. So again, this is up there on the second order of precedence in the what will the CLI use when you're making calls to the CLI. These are a couple of the environment variables that I use pretty frequently in scripting. First one here is AWS_profile. And that's going to tell the CLI which named profile to use so that you don't have to say -- profile dev on the command line. If you would have exported this variable to tell the CLI to use this named profile, it will just continue to use that profile until you tell it otherwise or override it on the command line with the -- profile parameter. And then again, here's another example, just setting a default region, so similar concept there. Okay, so this is an example of a function that allows you to quickly and easily switch between profiles. So this is a shell bash function. What this does is leverages that environment variable and exports it to set your current active credentials on the AWS CLI. So if you have a lot of different name profiles inside of your AWS CLI configuration and you're switching between different credentials to access different accounts or access different environments, switching profiles or specifying -- profile on every command is not something you're probably going to want to do. So if you create a function similar to this and then leverage it, you can just from the command line run something like sp dev space dev, and then now you've activated your dev named profile. And this is something I put in my .bashrc file. As mentioned previously, all of the code examples are going to be in my GitHub profile, my GitHub repo that is linked at the end of this presentation. So if you'd like to leverage this, you're more than welcome to. So let's run some commands, talk about the AWS CLI some more. So this is the AWS EC2 describe -instances --instance -IDs. And then we have a fictional EC2 instance ID appended there to the end of the command there. AWS calls the EC2 portion of this the command. When you're looking at the AWS CLI documentation, they call EC2 the command, and then describe -instances is what they call the subcommand. So if you're looking at the docs, just be aware that that's kind of how they reference these different pieces of the AWS CLI. So the command EC2 is going to reference really the service that you're interacting with, and then describe -instances is the subcommand, and each service is going to have many, multiple subcommands that you can run against that service. You're going to have optional parameters and you're going to have required parameters depending on the subcommand that you're working with. This particular command has no required parameters, so if you run this without that --instance -IDs parameter, it's going to attempt to return information about every single one of your EC2 instances in the current region, which is going to be a lot of information. So if you want to get information about just one of those instances, this is how you would do it using that optional --instance -IDs parameter. This is another example of a S3 is the command, or the service or the API you're interacting with, and then ls is the subcommand. And in this case, in my example, I've specified -- profile space prod, and that's activating that named profile named prod that I talked about earlier. And that's an optional parameter there again, so that's not something that you would need to do. The majority of the AWS CLI subcommands return data in a JSON output format, so you get these very long large objects that contain all of the metadata about an instance that you're describing, or various types of information. The S3 command is a notable exception. Of course, S3 was one of Amazon's first services, or the first AWS service, and so that command actually doesn't follow the pattern of the majority of all of the other commands and subcommands. It does not return in a JSON output. But there is an S3 API additional command that has its own subcommands that do return in JSON output. Here's another example, AWS command RDS describe -db -instances subcommand, and then we're appending the --region optional parameter there to tell it to query that US East 1 region. Next example, AWS guard duty is the command, list -findings is the subcommand. And in this case, this subcommand actually has a mandatory --detector -ID parameter that you must specify. And when you're using the AWS CLI, and if you attempt to run a subcommand and you don't provide the required parameter, it will happily inform you that you missed something that's required, and then you can attempt to do it again. Last example here, AWS ELBv2 is the command, create -load -balancer is the subcommand, and in this case I've got a mandatory parameter again for the name of the ELBv2 that we're creating. Okay, so if you're using the AWS CLI and you're wondering how to use a particular command or subcommand, you can leverage the help. So the way to leverage help with the CLI is to do AWS command help or AWS command subcommand help. So don't do -- help like I do almost every single time. Just do space help, and that'll get you the info you need for using a command which will list out all of the available subcommands. Or if you're doing help after a subcommand, it will tell you about the subcommand, what's required, what's optional, give you all the information on how to use that. So as I mentioned earlier, the majority of AWS CLI subcommands will return JSON output for you to wade through. And this is a quick example of the information that is returned when you do a AWS EC2 describe - instances command, subcommand. And as you can see, there's a lot of metadata associated with an EC2 instance, and this isn't even all of it. It couldn't all fit on the screen. So when you want to do some scripting and you're looking for maybe one piece of information about an EC2 instance, getting a huge JSON object that contains dozens of lines might be not what you were looking for. So we're going to talk about how to deal with that in a couple of minutes. Okay, so let's get to the good stuff. And the good stuff is what I have defined here as using -- filter, using -- query, -- output, and then using shell command substitution and using bash functions. So we're going to talk about each one of these next. Okay, -- filter. Filter is a parameter that is available on some, but not all, AWS CLI subcommands. And it also varies, the support for filter varies by the subcommand. So some AWS CLI subcommands support filtering by just about every single piece of metadata that exists on the object, and others might only support filtering by one piece of metadata on the object. So it's up to the service team to build in what support they deem is necessary or what they want to do for a particular subcommand. But it can be very useful. In this case, I'm showing an example of where I'm doing describe - instances, and I'm doing a -- filter on a tag on EC2 instances, and then in the values, I'm putting in an instance name. So if, for example, you knew the name of an instance or how you've constructed the name tag for that instance, but you didn't know the instance ID, this would allow you to just return data for that particular instance utilizing its name tag without having to know the EC2 instance ID, that long I- alphanumeric string that AWS assigns as unique identifiers on EC2 instances. So filter can be very handy, but you have to keep in mind that it's not supported on all commands and subcommands. Okay, -- query. -- query is a parameter that leverages JMESPath query language to allow you to pull specific pieces of information out of that large JSON object that you're going to get returned back from AWS. So in this case, in the example here on screen, I am running an AWS EC2 command, describe - instances subcommand, and then I'm using the -- instance -IDs parameter to specify a single EC2 instance. And then I'm using -- query to dive down into that very large EC2 JSON object that gets returned to us about that EC2 instance. And instead of pulling all of that information back, I'm telling it with JMESPath, with -- query to dive into the reservations, square bracket, .instances, square brackets, .private IP address piece of data from that EC2 instance. And instead of getting dozens and dozens of lines of data about that EC2 instance, now I'm just going to get back its private IP address. So this can be very useful in scripting, in setting variables in your shell scripts to particular information about an EC2 instance that you can use later. And I'm going to be talking about that as well. Okay, you can also do filtering with query. So a second ago I mentioned that -- filter isn't supported on all commands and subcommands, but -- query is on all subcommands that return in a JSON output. Also, -- query is very similar to the JQ utility. So if anybody's used JQ, same type of query language, that's JMESPath query language. You can go to jmespath.org and look at the specifications for the query language to learn a little bit more about how to use it as well. In this case, I'm doing an AWS RDS describe -db instances, and I'm leveraging -- query again here. And instead of just pulling out one piece of information from one particular instance, in this case, I'm querying all DB instances for my current region, and I'm getting the DB instance identifier for every single DB instance, but only if that database instance has the auto minor version upgrade metadata set to true. So if you wanted to know which RDS instances in the current region are going to do auto minor version upgrades automatically, you could get that really quickly and easily using this AWS CLI command combined with -- query. JMESPath also has functions. So if you really need to do a lot of manipulation with the output of your AWS CLI commands, you can take a look at the available functions in the JMESPath query language. In this case, on screen, on the example here, I'm using the starts_with function to filter some of the output, and then later I'm also using a sort_by function as well. So there's lots of different things you can do with JMESPath query language, and depending on your needs, you might need to look into what's available there and how to filter, sort, manipulate, the output that you're getting back from the AWS CLI. You can also use -- filter and -- query together, and this is an example of that. In this case, I'm doing another AWS EC2 describe -instances subcommand, and we're filtering on the name tag again, and then with the -- query parameter, I'm just pulling back the private IP address, and then also I'm using -- output text. So output text is important and useful when you're doing scripting, especially if you want to set the a shell variable to the output of this command. You're going to want to output in text so that it doesn't also return a set of square brackets on new lines as well. So again, in this example, if you knew a name of an EC2 instance, you could then query the AWS CLI and get back its private IP address quickly using this AWS CLI command. I mentioned output a second ago, and that again is useful for returning that one piece of data just on one line without the square brackets getting in the way on additional lines. Okay, let's talk about command substitution. So I mentioned that you might want to set a variable to be used later in your scripting to the output of a AWS CLI command, and this is exactly an example of that. So in this case, I've got a variable named IP_address, and I'm setting it to the output of an AWS CLI command. So it's a similar command that we showed on the previous slide here. We're going to use -- query to return just the private IP address of the instance we're targeting. Output is text, and that's going to be set to our IP_address variable here. So if we, after running that top command, do an echo of the IP_address variable, we're going to get that piece of data back that we can use later on. And I'm talking about, I'm focused here on Bash. You can do similar things with other shells, Z shell. If you're on Windows, I have validated and checked to see that all of this does also work with Cygwin and also on the Linux subsystem for Windows. So you can leverage these things on the Windows platform as well. All right, want to talk about positional parameters really quick, and this is shell scripting basics here, but this is a beginner class, so let's talk about it really quickly. The way that shell scripts and functions work is that they take positional parameters as arguments. So in this case, I've got a script named your_script.sh that I'm calling from the shell, and that can be a script or a function inside of a script. And we also pass it a positional parameter. So the first positional parameter is going to be referenced as $1 inside of your shell script, and the second one is going to be referenced as $2, and so on and so forth. So just wanted to quickly go over what positional parameters are by showing this slide. And the same thing occurs when you're calling a function inside of your shell script. So you call a function, you can pass your function a positional parameter or multiple, and then inside of your function, it will refer to those positional parameters as $1, $2. Okay, so let's talk about functions now. So when you're defining a shell function, this is an example of one here. It's essentially going over the syntax here. You pick a function name. You have to use the parentheses and then curly braces to encapsulate your function. And in this particular function, I'm going to set an ID variable to the value or the output using command substitution of an AWS CLI command, like we showed previously. And then after that, we do an echo of that ID variable to print out what we have set that variable to. So you can use shell functions to wrap AWS CLI commands to make them useful and to call them multiple times inside of your shell script. Okay, so let's script it. So I'm going to be talking about a script that I wrote. This is an example of ways to leverage all of these things we've talked about so far, where the AWS CLI is used to stop and then start an EC2 instance, all from the CLI in an automated fashion. You don't have to go into the web UI and keep clicking refresh to find out when your instance is stopped. The script does it all for you. So we're going to look at the code, and I'm going to walk you through the code and tell you exactly what the script is doing here. So again, this is the stop_start_EC2 script. The first thing that the shell script is going to do is we set -e at the top of the script, which means that if any of the commands or the functions return a non-zero exit code, which would mean an error has happened, we want to abort the script and stop. So that's what that set -e directive is doing at the top. First thing we do is we set a variable named ID to the first positional parameter that we pass to the script, which is going to be the instance ID we're going to use. Next up, we've got a sleep_duration variable that's just hard-coded to 5 seconds. After that, we've got a start_time function that is using command substitution again to get the start time of the script using the date utility. And then later we can calculate the script duration based on setting the start time and end time and doing some math there. First function is the check_parameter function I've defined here. And this is just doing some input validation for us. So this script requires that you give it an EC2 instance ID. And so we're going to echo the $1 positional parameter. We're going to use grep Perl compatible regular expressions here to make sure that the first positional parameter that was passed to the script actually looks like an instance ID. And so an instance ID should start with I dash. That's what those instance IDs look like. It should have alphanumeric characters, and it should be 8 or more of those alphanumeric characters. So if the first positional parameter looks like it should, it looks like what an EC2 instance ID looks like, then this function is just going to return 0, and our script can continue on. But if it doesn't, then we know that somebody made a mistake, and we're going to enter into the else block of this if statement. And then we can provide some output to the user that, hey, you didn't provide the parameter that we need. It doesn't look like an EC2 instance ID, and that's what we need to run this script. And then if they didn't provide it, the script would exit because we would return 1, which is a non-zero status code. And then the user could try again. Next function is a stop_instance function. So this function is a very simple wrapper around the EC2 stop-instances subcommand. And then we're giving it an optional parameter of, actually that's a required parameter of --instance-IDs. And it's going to use a $1 positional parameter that was passed to the function. So this function has to be called with the instance ID after the function. Next function is very similar, start_instance. It's doing the same thing. Requires a instance ID to be passed to it. Next function is a check_status function. So what this function is going to do is do a EC2 describe-instances command and subcommand again. Pass it an instance ID. And then we're using that --query parameter we talked about earlier. And this is going to allow us to dive into the big JSON output for that EC2 instance and only pull out the state.name of the instance, and output is text. So an EC2 instance state could be running, it could be stopped, but it could also be starting or stopping. So we want to make sure it gets into a certain state, we have to check the state of an instance. Next function is check_running. This function is going to call that function that we talked about above, check status, and set it to a status variable here. So status is going to equal running, stop, starting, one of those instance states. And then we've got an if statement that says, if the status is not equal to running, then we're going to print a message that says we can't restart the instance because its state is not running. So this script assumes that your instance is running because you're trying to stop and then start it. And then we're going to return 1 if it's not running because it's not in a state that we want, and that will exit the script, again, because of that set-e directive we had set at the top of the script. Next function we have is the function wait_for_status function. So this function, again, is setting a status variable, similarly to the function we talked about above. And it's going to call that check_status function that we defined above again, using query to only pull the status of the state of the instance out of the EC2 object that gets returned to us. And this is where the magic of this script happens. We enter into a while loop here, and we're going to say while the status is not equal to the second positional parameter that we pass to the function, then we're going to say, we're going to print a message to the user that the instance state is not yet that second positional parameter. And so we're going to sleep for a sleep duration, which we have as 5 seconds. And then we're going to check the status of that instance again. So this allows us to, if we've stopped an instance, if we want to check for when it has stopped, we can call this function using the instance ID as the first positional parameter, the state of the instance we want it to be in as a second positional parameter, as we show down here. Instance ID's first positional parameter, stopped is the state we want it to be in. It will allow that function to essentially continually query AWS in 5-second intervals until it enters into that state that we want it to be in. So then we can know exactly when our instance has reached a desired status so that we can continue out the script and do the further actions that we want to occur, without having to, again, manually look in the web UI to figure out when our instance reached a particular status. So at the bottom here is the main runtime of our script, and we call all of those functions that we talked about. And I'm happy to talk about this script and similar scripting you can do with the AWS CLI. I need to wrap up my time here, and let me pull up the code and the presentation links. If you want to download the presentation, I've got the link here. The code is in this GitHub repo. I'm going to be outside this room for a few minutes. I've got some Pluralsight fidget cubes and multi-tools and Pluralsight free trial cards. If anyone's interested, you're welcome to come on over and grab one or a couple of those and talk to me. Happy to answer any questions. Thank you very much.